Now Newton's second law of motion that states F equal to ma. Now we will see how to derive this. F is the rate of change of the momentum that is equal to the force. That is according to the second law of motion. Suppose an object of mass m is there, it is moving, but the initial velocity is u. Object is at rest with initial velocity u. Then force F is applied to the object. Force F is applied to the object for time t. So it reaches at some distance and then that final velocity will be v. So in this case the momentum is given as mv, mass into velocity. Momentum is equal to mass into velocity. But here there is initial velocity and final velocity. U is the initial velocity and V is the final velocity. So we have to write first initial momentum. Initial momentum will be mass into velocity. Initial velocity, that will be mu. Then final momentum of the object, that will be mv. Now we have to see the rate of change of the momentum in time t. So we have to take this final momentum minus initial momentum upon t, because that is the rate of change of the momentum over time t. So we get, when we put the value of this, final momentum is mv, so mv minus initial momentum is mu upon t. So m will be common in this and we get v minus u upon t. We can write it as m into v minus u upon t. But we know that a equal to v minus u upon t. This a is acceleration. A is acceleration. That is equal to v minus u upon t. So we can replace this with a. So putting this value here, we get p equal to m a. M, and instead of this we write a. But as per the second law of motion, the rate of change of momentum is directly proportional to force applied. And so we have F is proportional to ma, mass into acceleration. So remove this proportionality sign and we put some constant, proportionality constant. So it will be F equal to k ma. K is the proportionality constant and the value of k is 1. So we get F equal to ma, the force applied, that is equal to mass into acceleration.